Alright, so in the next part of this video, what we're going to do is after we've done some simplification, we're just going to be doing more proofs of identities, which again is just more simplification, where we're trying to make one side look like the other. So when I look at this guy, right, I'm thinking that side looks like the most complicated because I see a quotient, and that's usually a bad idea for what we have here. Excuse me. So how about we start with that? So we can begin this one by recalling what is the cosine of a difference is. Well, that's the cosine of the first, cosine of the second, plus the sine of the first, sine of the second. And so this is all divided by cosine and sine. Now be careful here, right? We're dealing with a plus sign right here. Let me change colors here. We're dealing with a plus sign. So this basically breaks up into two fractions. So we got the cosine of x, cosine of y, all over the cosine of x, sine of y, plus the sine of y, the sine of x, sine of y, all over the cosine and the sine. Okay, so after we break it up, we can see that there's some dividing out, and we're left with cosine over sine. Well, we know that to be the cotangent of y. And then over here, after the canceling, we got sine x over cosine, which we know to be tangent of x. The only thing that's different here is that the sum is written in the reverse order, but we know that addition is commutative, so I got it. All right, this and this are the same. Tangent of x plus the cotangent of y. We verified the proof, and we're all set to go. All right, so there you have it. The next one, there's something a little tricky about this one because we have the cosine of a double angle. And what's really interesting, I'm kind of sneaking, this is a sneak peek into 5.5. I also have the same cosine of a double angle, and it's equal to something else. So that shouldn't be any surprise. As we've seen, we can rewrite something several different ways with my identities. And so it turns out that the cosine of 2x is actually equal to at least two different things. You're going to find in 5.5 it's actually equal to more. And maybe even as you do your homework, I think the book goes through some others. So how do we begin something like this? Well, why don't we begin with the cosine of 2x here and rewrite that as the cosine of x plus x, right? Because x plus x is 2x. That helps me out here because this is now, right, the cosine of a sum. So using our identity, it's the cosine of the first times the cosine of the second. It's plus, so we're going to get minus the sine of the first and sine of the second. And so at this stage, we have cosine squared x minus sine squared x. So that's what our rewrite and our cosine of a sum gets us at this point. Looking at this, we want just a cosine squared. So there's a cosine squared there, but can we rewrite this? And the answer is yes. Right? We know that we can rewrite the sine squared as 1 minus cosine squared using our Pythagorean identity. And so rewriting this, we get cosine squared x minus 1 plus a cosine squared x. And of course, a cosine plus a cosine is 2 cosine squared x minus 1, and the identity is proven. All right, so there you have it. So what about the next one? How do I prove that cosine of the double angle is equal to this crazy cotangent squared x minus 1 divided by cotangent squared x plus 1? Well, this trick's probably not going to work, right? Because this is pretty clean, and it's going to be really hard to get that quotient in there. So typically, again, what we do is we work with the worst side first. And what I'm seeing is how about we just change things to sines and cosines. So cotangent squared, that would be cosine squared all over sine squared minus 1 upstairs, and then a cosine squared x and a sine squared x plus 1 on the bottom. All right, so there's that. My next move, algebraically, what I have to do, as long as I do the same thing to both upstairs and downstairs, I'm okay. So to get rid of this fraction, there's a couple of ways we can do it. We can perform the subtraction and addition, just get a common denominator, and this would be sine squared over sine squared. But the trick I'm going to do is I'm actually going to multiply the numerator by sine squared, which means what do I have to do on the denominator? The same thing. So whatever you do to the top, you do to the bottom. So hopefully all that fraction work that I've made you guys do, there's a payoff here again in our algebra. So to simplify this crazy fraction, I'm basically going to multiply the top by sine squared and the bottom by sine squared. I chose sine squared because it's the denominator. So if we distribute, the sine squareds are going to cancel out, leaving us with cosine squared x minus sine squared x on the top. On the bottom, when we distribute, the sine squareds will cancel out, leaving us with cosine squared x and then plus sine squared x as I do that distribution. On the bottom, we know that to be 1. So we have cosine squared x minus sine squared x, and this would be cosine squared x minus sine squared x. And I'm going to say I'm done here because if you look over here, right, we found that when I rewrote cosine of x plus x, after I used the identity, we got cosine squared minus sine squared. So we already know that this is equal to cosine 2x from another part of an identity that I've proven there. All right, so there I've proven that this quotient does turn into the cosine of the double angle. And there's your round of proving identities, which is basically simplifying one side into the other by using identities and rewrites and a lot of algebra. Here we did a lot of fraction work to get where we needed. Here again I did some fraction work. Here I just used a reciprocal identity, and here I ended up using the cosine of a sum, and then ended up using a Pythagorean identity to rewrite to get what I needed. So again, takes lots of practice, takes a lot of skill, both algebraically and trigonometrically. So just keep practicing, keep working, put your ideas on canvas to give me an opportunity to criticize or to constructively criticize and help you guys out so you can improve. If you need more help, please come see me during an office hour. All right? One more video for this section, and that's coming soon.